3:17 UTC, telescopes around the world detected something impossible. A second signal from the Andromeda Galaxy, stronger than before, clearer, and unnervingly structured. In control rooms, scientists froze. It wasn't background noise, it wasn't random. It was deliberate. For the first time, they realized the universe might be trying to say something, and no one knows what comes next. Fast radio bursts. 3 words that sound straightforward, but behind them hides one of the great ongoing mysteries of modern astronomy. These are flashes of energy that travel across space at radio frequencies, lasting only milliseconds, yet carrying the power of millions of suns. They appear out of nowhere, no warning, no pattern, and then they vanish. Scientists detect them as sudden spikes in radio readings, short and violent, like sparks from a cosmic storm. Some come from across galaxies, others vanish before telescopes can even adjust to capture them. Over the past decade, hundreds have been cataloged, each labeled with strange codes marking where and when they appeared. Most are one-time events, with no repetition, as if the universe occasionally hiccups and then goes still again. But a few repeat. Those are the ones that cause sleepless nights among astrophysicists. Fast radio bursts are thought to originate from some of the universe's most extreme objects: magnetars, collapsing neutron stars, or black holes twisting magnetic fields to their limits. But here's the truth: no one has ever directly observed what creates them. The physics behind them is still uncertain, and every new detection adds more confusion than clarity. 18 months ago, one particular FRB drew attention: Wave 1. It came from the direction of the Andromeda Galaxy. It was powerful, distinct, and unlike the usual random flashes that come and go. Astronomers logged it, studied its wavelength, measured its dispersion across intergalactic space, and filed it away as a rare but natural occurrence. For months, it remained just that, another point on an ever-growing cosmic chart. A curiosity, but not an alarm, until now. What arrived next was stronger, stranger, and for the first time, it created a pattern that no one could fit inside existing models of natural behavior. That moment marked a turning point, when the mystery surrounding fast radio bursts turned into something deeper, something we might not be ready to explain. The second signal didn't just arrive, it announced itself. From the first millisecond, it demanded attention. Same coordinates as Wave 1, but this time the energy curve was off scale. The pulse didn't fire once and vanish. It came in a series, structured bursts, almost rhythmic, lasting nearly 10 full seconds. Automatic classifiers instantly failed. The algorithms that filter radio data into known categories returned a blank output, unidentified source. Usually, cosmic events spread their energy randomly, scattering across frequencies. But it formed a pattern, a pulse that repeated with perfect precision, as if obeying a metronome. Imagine lightning striking the same spot every second, to the exact millisecond. That's how unnatural it looked. Scientists rechecked their systems, assuming interference or equipment failure. But when observatories on opposite sides of the Earth confirmed identical readings, all doubts collapsed. The structure was real. The polarization, the twist of the electromagnetic wave, was dancing in perfect rhythm. It wasn't chaos, it was order. The realization sank in slowly. This signal wasn't just stronger, it was designed. Whether by physics or intention, it carried coherence far beyond anything the universe usually produces by chance. As the data accumulated, one final entry appeared on the report that sent chills through the teams monitoring it. The pattern suddenly shifted, as though adjusting to compensate for our atmosphere. No natural source should know we exist, let alone react to our planet's position. From tension came silence. Instruments recorded the tale of the waveform fading into nothing. It left behind only numbers, unanswered questions, and the uncomfortable sense that something out there might, in its own way, be listening back. 4 minutes after the signal from Andromeda faded, Earth's magnetic field flickered. Sensitive instruments around the globe registered a brief compression, a sudden invisible pulse squeezing our planet's protective shield. No solar flares, no storms on the sun's surface, no cosmic event nearby could explain it. This was something new, something unexpected. Multiple space agencies confirmed the event independently. Satellites in orbit recorded the same compression, while power grids showed faint, unexplained fluctuations. Curiously, when scientists revisited data from the first wave, they found a similar but milder effect, one that had gone unnoticed amid the noise. It was subtle but consistent. This wasn't a coincidence. It was a connection between a distant burst and our world's magnetic heartbeat. Scientists grappled with disbelief. What could cause a signal from 2.5 million light-years away to affect Earth's magnetosphere? For now, no answer exists, but the question lingers and deepens the mystery. To understand just how extraordinary the second signal from Andromeda was, scientists crunched the numbers. Fast radio bursts are already known for their immense energy, but Wave 2 shattered all expectation. Using the inverse square law, which tells us how energy spreads out over distance, researchers calculated the original power output needed to be detectable here on Earth. The result was staggering. Imagine a flashlight shining from the moon so bright it outshines the sun in broad daylight. Now multiply that brightness by 1 billion. This is the scale of energy we're talking about. Wave 2's energy release outperformed every known cosmic explosion, far beyond the physical limits set by our current understanding of physics. Yet, This overwhelming raw power was only part of the story. The energy alone doesn't explain the signal's intricate pattern, its perfect timing, or how it appeared to interact with Earth's magnetic field. This implies there's something deeper, something bigger, lurking behind the numbers. As scientists delved deeper into the data, they uncovered something remarkable. Beneath the chaotic burst lay a precise, repeating structure in the timing of pulses. The intervals between pulses followed a pattern of doubling, 43 milliseconds, then 86, then 172. This binary sequence repeated consistently throughout the signal. Across multiple observatories and instruments, the same pattern emerged, unaffected by noise or distance. The replication was too precise for chance. Such a pattern suggests intelligence, or at least design. In nature, random processes create random intervals. This was deliberate. The structure resembled encoded digital communication, simple, elegant, and consistent. If this is a message, then it's written in the universal language of math, hiding in plain sight within the noise of the cosmos. This discovery marked a turning point. The signal was no longer just mysterious, it was potentially meaningful. Faced with data that challenges everything, scientists have proposed several possible natural explanations, each impressive but incomplete. One idea points to magnetars, neutron stars with intense magnetic fields. They can release bursts of energy through plasma acceleration, but their signals are typically chaotic and unpredictable. The rhythmic, repeating pattern we observed doesn't match that. Another theory involves galactic flares or extreme lensing effects. These could amplify or distort signals, creating echoes or repetitions. Yet these phenomena themselves are highly unstable or theoretical at such precision. Some physicists explored new models involving exotic matter or unknown plasma behaviors, but these remain speculative, lacking concrete evidence. The consensus in published studies leans strongly towards natural origins, mainly because science demands extraordinary evidence before accepting anything else. However, the sheer precision, energy, and Earth's response resist fitting neatly into conventional explanation. Behind closed doors, many experts admit a silent unease, a sense that they might be confronting something beyond current scientific models, something that blurs the line between natural and engineered. Science demands patience and caution, but also relentless curiosity. This signal defies easy answers. We don't jump to conclusions. Instead, we eliminate impossibilities, and in doing so, reveal how little we truly understand. The signals from Andromeda took 2.5 million years to reach us, traveling across an almost incomprehensible void of space and time. To put it in perspective, these waves began their journey when early humans were still developing basic tools, predating even ancient civilization. This enormous distance means the bursts contain a story from a time long before modern Earth existed, a time when life was just beginning its first steps on this planet. The universe, in this sense, feels like a vast cosmic message board, with signals traveling across epochs waiting for us to finally intercept them. The 18-month gap between Wave 1 and Wave 2 might or might not hold significance. Time at such scales is relative and ambiguous. What seems like a long pause to us could be meaningless in the context of galactic events, or a deliberate pattern spanning millennia. Beyond the staggering distances, the very fact we're receiving these bursts now suggests a universe that might be more connected than we often realize. These waves could be part of an ongoing conversation or a longer message thread, perhaps continuing long after their originators have vanished. The possibility that more waves are still en route, traveling silently through the cosmos, opens endless questions. What else awaits? What truths about the universe or life are hidden in signals yet to arrive? Far from a silent void, the cosmos might be alive with echoes, messages embedded in the turbulence of space and time. Each wave arriving here becomes a bridge to a mystery far greater than ourselves, inviting us to listen, to decode, and ultimately to understand our place in the grand cosmic story. What might already be flying across the intergalactic abyss toward us, patiently waiting to change everything we think we know. We have two confirmed signals, matched in location, timing, and an unmistakable structure. Earth itself reacted in ways science cannot fully explain. Every test confirms these bursts are real, deliberate, and powerful beyond precedent. Yet no current natural explanation fits all the facts. Magnetic fields, plasma physics, galactic phenomena, each theory falters when confronted with the full dataset. The precision, energy, and Earth's response remain puzzles. So what are we looking at? Could this be new physics? Phenomena beyond our current grasp? Or could it be a message sent intentionally across millions of light years? Either answer defines a new chapter for humanity. If natural, we're witnessing cosmic forces more complex and structured than we imagined. If engineered, we stand at the threshold of a dialogue between worlds, one that began long before humans existed. Both possibilities are staggering, humbling, and profoundly exciting. Andromeda is no longer just a distant galaxy. It's a beacon, a message, an open question. This is where science meets wonder, and we must listen carefully. This story is unfolding right now, and every new signal could rewrite what we understand about the universe. We'll be here, tracking every wave, every pattern, every mystery. Subscribe and join us on this journey. Together, we'll watch the cosmos speak, and when it sends the next message, we'll listen, live. Your curiosity shapes the story. Don't miss a moment.